We square both sides, and we get e squared. We square this. Z sub alpha over 2 is just one number. And then I have squared, when I square square root, I get p hat, 1 minus p hat divided by n. From here, I cross multiply, and or switch these two in a proportion. I can do that. In case you don't remember, I will show you. I'll multiply both sides by n. So then e squared times n equals z squared sub alpha over 2 times p hat times 1 minus p hat. All I have to do is divide by the error squared. So this is how we get this formula. So d squared is sub alpha over 2 times p hat times 1 minus p hat. So this is the sample size for a given margin of error. So we want to, once we have E and alpha, then we can determine the sample size and p hat, of course. An economist wants to know if the proportion of US population who commutes to work via carpooling is on the rise. Fine. What sample size should be obtained if the economist wants an estimate within 0.02 or 2%? It says 2 percentage points, an estimate within 2 percentage points, which means that's the error, E, of the true population proportion with 90% confidence. So 90% confidence. Okay, let me write it so it's clear. Fine. All I have to do is just plug in the numbers. Okay. Part A, assume that the economist uses the estimate of 0.10, so p hat, or p if you want, is 0.10. Any questions so far? Okay, so we are given p hat equals 0.10. We are given E as 0.02. Now we have to identify Z. We need to identify Z alpha over 2. Fine, no worries. Can anyone tell us what is the distribution of Z?
0,1.
Yes, so it's normal with mean 0, standard deviation 1, so this must be 0. And the 90%, okay, this is the 90%. Now what do we have in the tails then? If the middle side part is 90%, what do we have in the tails? Oh, that's not good. How much? In each? From 100%, I subtract 90%, I get 10, so this must be 5%, and this must be 5%. And with the inv norm, with the area of 0.05, I will be able to determine the Z, alpha over 2. Inv norm, please. Inv norm, the area to the left, 0.05. Yes, this is very important. If I don't know what to plug in here, 0 and 1, then I will not get what I'm looking for. And I want Z, the Z score here. What is it? 2 point what? Well, I'm sorry, it's 90%. 1 point, so this is negative 1.645, and this is 1.645. We are only using the positive, of course. It doesn't matter, actually, we have to square it anyway. So the sample size will be Z alpha over 2 squared, 1.645 squared. Our p hat, 0.10 times 0.90, because 1 minus 0.1 will be 0.9, and everything divided by the error squared, 0.02 squared. Okay, ready? Let's put in the calculator. Be very careful. Because they're all multiplied, it will work without parentheses, but normally we should put parentheses around the top and about around the denominator. Okay, so left parenthesis 1.645, no, 645 squared, and then multiplied by 0.1, multiplied by 0.9, close the parenthesis, and we divide, no, I didn't mean that. So 1.645 squared times 0.1 times 0.9 and divide by 0.02 squared. So I got 608.8. I'm going to say 609. Oh, 609. What we wanted is population, proportion, economist, people. So 609 people have to be surveyed in order to ensure a margin of error of 0.02 and ensure that this is a 90% confidence. Now, part B. In part B, in part B, we're asked, assume that assume that the economist does not use any prior estimates. So these were prior estimates, meaning we were given p hat 0.110. This was a prior estimate from a different study from 10 years ago, who knows? We don't have that now. If we don't have it, we will assume p hat is 0.5. And we will calculate the same, and equals 1.645 squared times 0.5 times 0.5 over 0.02 squared. All the same, because if p is 1.5, p is 0.5, then 1 minus 1.5 is still 0.5. So because they are all squared, I can do this. Parenthesis 1.645 times 0.5 and divide by 0.02, and then I square the answer. 1691.26. 1691.26. I will select 1692 people. A simple random sample with 1692. 1,692. We didn't get the chance. It was I should have stopped and done more problems from, but that's what we're going to do next time. And I think that maybe in a way it's better if you do the interactive